Hey everyone, in this video I will do linear regression from scratch with just pure Python. So the only external library I'm going to use is NumPy and otherwise nothing else. So before starting the code, this is a quick 3 points to know about linear regression. Probably you already know if you are aware of this most fundamental and most popular and most useful algorithm in the world of machine learning. So here the notation is this, that hxi that represent the predicted value of regression line. Okay, first is any line in the linear regression is presented geometrically as y equal to mx plus b. And then about these equations here, although they look a little bit bigger here in this picture, but actually they are so simple. So we mainly, during the algorithm, we mainly have to update these intercept and slope. And the way that we update the intercept is with these two equations. So your new intercept or the updated intercept is your old intercept minus this whole term. And this term is alpha, which is a learning rate, multiplied by 1 by m. M is the total number of rows in your data set. And then summation of hxi minus yi. Similarly for the slope, old slope, the updated slope is old slope minus this whole term, and the term here only difference with this one and this one is a dot product between this summation term and xi. And how we arrived at this term, that's the situation when we calculate the derivative of our cost function. So this what we are seeing is actually the result of the derivative, and that's where the concept of gradient is being applicable. So for this term, this whole derivation of the derivative I am putting here, just in case you are interested. You don't actually need to know each of the steps just to implement the linear regression, because linear regression you already know the result here, and I'm directly going to apply this formula to build the linear regression algorithm. But this is a mathematical derivation of how the partial derivative of cost function with respect to del m is calculated here, and very simple, just 2-3 steps, pure algebraic things. You go line by line. Similarly, for this one, that is for our case here dc, where the cost function partial derivative with respect to your c, that's the steps it is calculated, and again pretty much simple steps. And the final result, what we see here and here, that's exactly what is included in this formula. So I'm directly going to take this formula and implement the Python implementation of linear regression. All right, so that's I'm done with the actual implementation. Now just create some dummy data to check that it's actually working. Now just the plotting. Let's quickly check if everything is looking all right. Oh, I made a little mistake here. Because this is a regression problem, this will be make regression. Yeah. All right, everything looks good. I just copy the entire thing and take it to Jupyter Notebook. That's my Jupyter Notebook, and I just paste it in a cell and run the cell. Yep, I got the output as expected. So these green and deeper green, these are all the scatter points, and this is my regression line representing these actual data points scattered across. Alright, that's about this video. If you liked it, smash the like button and also do subscribe, as I'm trying to upload one video almost every single day. So see you in the next one.